Bilal, okay.
Yep, Bilal reply okay already. All right, let's look at question 4. All right, now look at your tutorial question, question 4. So you're given a statement, always you'll see a statement. So given airflow steadily between two sections and given a diagram there. So it's a long straight portion with 4 cm. Again, this one is a trap for you. If you're not careful, you straight away use a 4 cm already. Remember to change to unit SI. So you have a 4 cm, inside diameter is given. 4 cm inside diameter. So this one is a DI or the fluid cross-section area. Uniformly distribute temperature, pressure of each section is given. So in the diagram there, you see P1, T1, P2, T2. So in this diagram, you're seeing Celsius. Now, average air velocity, non-uniform velocity distribution at section 2 is 1000 cm per second. Again, this one is also a trick question. Use cm. You should convert to meter later on. Assume air as ideal gas. So in the introduction to fluid mechanics or thermal fluid, we already cover what is the ideal gas. But again, we will see ideal gas in the later chapter. So calculate the average air velocity in section 1 with this here. Okay, with this here. And you see all these symbol. It means something else. Okay. Now all these are highlighted keyword. You need to recall what is ideal gas principle. And we need to calculate average air velocity. And it tell you some keywords here also hidden in the statement. Air flow steadily. It means steady flow. Okay, it means steady flow. Yeah. Okay, and uniformly distribute temperature and pressure. This one also give you some hints that is a stable system. Okay, I just extract everything that we know in the diagram here. So we do not know what is velocity in section 1. And then we have 4 cm inside diameter here. And then we are given V2. Flow is steady. And again, we always draw our control volume here. Flow is from the left to right. And yeah, this is the definition of the red color. The red color, I think you don't have this one. Huh? So it just additional information. Later we'll look at conversion between these two diagrams. So the red color means the velocity profile is not uniform. The red color is a parabolic shape. It means that the red arrow, the profile is non-uniform, the red color. And then the dark blue color, a navy blue color, it means this is a velocity, uniform velocity. We use the denotation of V hat, V straight hat. It means it's the average velocity. It means we assume the non-uniform velocity in section 2 as uniform V. Means we assume that we transform the red color into the blue color so that we don't need to calculate the profile. We simplify the case. Huh? Okay, right. Now again, we start with the continuity equation. Every time you see steady flow, straight away the next step is continuity equation. So again, write out the continuity equation. One component on the control volume, one component on the control surface. And every time you write something, the correct equation out, you get 1 mark. Okay. So in the exam, don't leave your answer blank. At least write something. at least you define the question, right? Of course, you don't copy every equation. If you copy every equation, then it means you just guessing, then you won't get marks. Right? So call out the continuity equation, CV component and CS component, control volume component and CS component. Write this one out and then define steady flow. Draw this arrow equals 0, right? Or you just straight and then write steady or steady flow. This one, I'll give you 1 mark. Then the rest you only have rho V dA. This component again is m dot out minus m dot in. Mass flow rate in minus mass flow rate out. And recall the definition of m dot. M dot equal to rho AV. You will see the standard procedure here. Always have the flow. Always have the procedure. Step 1 do what, step 2 do what, step 3 do what. Right? What will change in the question is all these parameters and the shape sometimes. Okay. The first thing you see steady flow, call out the continuity equation, cancel one of the component because it's steady, and then continue with the second component, m dot. So you have rho AV, V out equal to in and out. Now just now I explained, we use average air velocity for the non-uniform velocity distribution. We use a V hat, use V hat. So we write our equation like this. Rho A V hat out equal to rho A V hat in. We change this term into average air velocity. This is the fourth method that we mentioned in our first slide, simplification. This is a simplification application. Means when we analyze problem, we use the simplification. Okay. So we have this one. And again, this scenario is compressible. Question 3 is incompressible flow. However, this one is compressible. Why? Because in the question just now, here, when you have a non-uniform velocity distribution, means you have a compressible flow scenario. Okay, this is an indirect meaning of compressible flow. Okay. So because of compressible property, then your density will not same. Density in this equation will not same. So later you need to define this one rho out. This one is rho in because these two is not same in a compressible scenario. Okay. So you continue with the calculation. Because the density is not same, however, what is same? Because it's a straight pipe with the constant area, then your A is same. When you find something same, you can cancel out in the equation. Just draw the 2 arrow there. Of course, in exam, when you cancel something, make sure you explain it. Right? You don't just cancel and then you leave blank. Then you let me guess what you are trying to say. Okay, so in exam, you do cancelling and then you write something A is same. This statement give you 1 mark. Then you cancel. Then you continue with the calculation.
Sir,
yes.
Can you repeat how the A is same?
Because it's a straight. Okay, in the question there is you see here 2 section long and straight. Long and straight. It means here to here there's no change of cross section. If you cut this one, you calculate the area. You cut here, calculate the area. it will be the same, right? Because it's a long and straight statement.
You mean for the control volume, right?
Yes, inside the control volume here.
Okay, I got it.
So in the statement here, they state long and straight. The keyword is straight. Long and straight means the cross section is the same. It's a hidden meaning. All these are hidden meanings. All right. Okay. Now cancel out the A. We label, of course, section 1 and 2. Row 2, V hat 2. Again, this one is the average velocity. Average velocity. Row 2, one side, section 2, one side, section 1, one side. And then you move it. You want to find the velocity here, V1. So you move your equation in the term that you want to find. So V average V1 equal to row 2 divided by row 1 times the V2. This one from mathematics. This one from mathematics. Now assume act as an ideal guess. So when you see this one, also give you some hints to call out ideal guess principle, which is this one. Okay, rho equal to P equal to rho RT. P equal to, if you want to remember this in this form. Some people like divide one, some people like straight like this. Okay. So every time you see this keyword ideal guess, you need to write this equation, either in terms of P, in terms of R, in terms of T, but you need to call out this equation. Okay, why we fix with the row? Because we need to find row here. We do not know the row, so we need to find. There's a reason why it gives you temperature here. Why it gives you T1 and T2? There's a reason. Because in the ideal gas equation, there's a T there. And then copy this formula somewhere in your notes. 0 degree C, you convert into Rankine, R, because the R constant here is in the unit of Rankine, R. Constant, gas constant is in the unit of Rankine. Joule over Rankine, right? So copy this conversion equation. So 0 degree C times 9 divided by 5 plus 491.67. You get the Rankine temperature. Again, ideal gas temperature in the unit of Rankine. Every time you use ideal gas equation. This is also the trick. So a lot of trick in the question, so be careful. Don't like, yes, Celsius is unit SI, but when you do calculation using ideal gas equation, remember on a unit. So you have two temperature here, you convert into Rankine. Convert into Rankine. Okay. Let me clear my slide. Okay. Then you write in the P term, T term, because we do not know the density here. We do not know the density here. We don't have density here, but we have P and T. And of course, in this case, we do not need to know the Rankine value. Air Rankine value, there's a R value for air, but we don't need that value. So you substitute this equation inside here, you simplify, you get this equation. Okay, from this one, you substitute inside here. So you have this term 2, this term 1. You simplify, cancel out the R. You get P2 divided by T2 times P1, T1 divided by P1. Okay, you do the mathematics arrangement. This one I will let you do as your homework. Go and study the mathematic arrangement. At the end, you get this one. Okay.
So, so you know what R?
In this case, we don't need R because why? Because let me do the expansion of this one is 1. R is constant for air because whether it's compressed or not compressed is still the same. So P2 divided by R T2, right? Now, if this one is too complex for you, you just write in mathematic form. Divide, right? Divide P2 R T2 equal P1 R T1. Divide, you can always convert as a times. You just flip the term here. Okay, R because it's the same, cancel out from here. Substitute back here. Because gas constant doesn't change. Each medium have its own gas constant. Nitrogen has one value, oxygen have one value, air have one value, and so on. Okay, you get V average V hat 1 equal to P2 divided by something, P2 T1 divided by P1 T2 times V2. So all these, so far we're still doing mathematics arrangement. Only need to remember to change your temperature into Rankine. Okay, remember to change this T1 and T2 is not Celsius. It should be changed to Rankine because you are using ideal gas equation. And Rankine, not Rankine, this R form, this R is a gas constant. R form is in the Rankine unit. So you need to change everything in the correct unit. Okay, let's clear this one. Right, again, the conversion for temperature. So T1, you get this value, T2 get this value. Then you substitute all the value, you get V1 equal to 228 centimeter per second. All right, centimeters per second. In the exam, remember to change to unit SI with the cm into meter. Okay, so we have done for question 4. So in this one, there's some trap or trick area. One is a unit that is unseen. In this question, you see Celsius. It seems that it's okay to use Celsius, but remember, it gives you some hints that it assumes air as an ideal case, where you use the ideal gas equation. So it is P equal to rho RT. Then remember to change to Rankine. And this conversion formula, please copy and then remember it, because in exam this one won't be given. You need to always remember how to convert it. Yeah. Again, is for this module, all your test question or final exam question will be on application. Yeah. How continuity can be used, and then you will be given some keyword to solve the question. Okay, now today we look at continuity equation. We look at two cases. One is compressible, one is incompressible. Maybe in your notes, in your tutorial notes there, just write question 3. Question 3, it will be conservation of mass, steady and incompressible flow. And then question number 4 will be also testing you on the concept of conservation of mass, but is in the steady and compressible flow. So these are the way we set question. You look for the keyword, and then you will know whether this one fall under which chapter. Each chapter have its own keyword. Okay, so we have clear for today chapter 2, question 1 to chapter question 4. We will continue the rest next week on Tuesday morning, very early morning. So make sure you set your alarm. I also need to come to office very early. So yeah, so let's remind each other. Okay, good. Let me end the recording.